Hi, I'm Rosie, and I'm currently a student of a BTEC Level 3 Diploma in Health and Social Care. So I'm just going to do a little video to explain what homeostasis is. So it's a Latin meaning for staying the same. So it keeps everything in the body the same, or regular, or in balance, however you want to put it. It's so our body don't get out of balance, or we don't get ill. Well, we still get ill, but you know. It's responsible for controlling and maintaining breathing. So I've got my little piece of paper here. Breathing. So it helps our respiration rate. So especially during exercise. So the amount of water in our body, or fluids. So it helps us to know when we are thirsty or if we need to urinate. So temperature. So we have an optimum temperature of 30 Celsius or below, but obviously not too low. Below 37 Celsius, sorry. So it helps us to maintain an optimum temperature because we have digestive enzymes and cells that need to stay at a regular, constant, good temperature. Glucose, that's sugar. So like our liver will store excess glucose if we've got too much, and that's with the help of homeostasis. Blood pressure, and heart rate. And it says breathing rate again, which I've already explained that at the top. So its associated system is the hepatic. It responds to changes in our body, so it carries on working even when our external, which is our outer environment, changes. So let's say if we go from outside in the cold to inside, it will still maintain our body. They have negative and positive feedback mechanisms. Excuse me, sorry. So each of the mechanisms will include a stimulus. So for example, the cold will stimulate a response, and then secondly a response in the brain or a processing centre to trigger the next step, which is an effector, which sends it back to normal. It has an automatic response, so then it will all return back to normal. So the importance of homeostasis. So it's more important in just maintaining our body. Sorry, it's a bit shaky. Important in maintaining our body. So maintain our temperature. My eyes went a little bit weird then. It will maintain our temperature in spite of what is outside. So it's important to maintain our inner body. So yeah, it just maintains all of that really. So if it weren't maintained, which is what homeostasis does, our body just wouldn't work properly. We wouldn't be able to produce or like fix cells. And like I said, digestive enzymes need an optimum temperature. We won't be able to exercise because our body just wouldn't be able to take that change in our body. So yeah, a lot of people say also everybody has homeostasis, so everyone's body will be the same, but that's not true. In lessons at my college, which is in Bristol, we discuss validity. So that's how valid results are after an exercise test, which is what we performed. So we performed it to know the importance of homeostasis and just to show us sort of how it works. So anyway, we discussed validity. So everyone's results varied, and some people don't really understand why they varied because everybody has homeostasis. But this is because homeostasis maintains your body for you as a certain individual. So if you're slightly more overweight, your results will be different, or maintaining, depending on your lifestyle. If you smoke, like for example mine varied from someone else's because I have Wolff-Parkinson's White syndrome, which is a problem with my heart, so that's bound to vary from someone who takes up regular exercise because they have a higher tolerance to exercise for a start. so their body can just take it more. So yeah, that's validity, just so you know. So yeah, I will explain to you a homeostatic mechanism now. So let's go for a homeostatic mechanism in breathing. So the body can predict a change that will occur before exercise. So breathing in starts off normal, and then exercise will start and the demand for oxygen becomes greater, and then the nervous system kicks in. Chemoreceptors in the body will detect a change in oxygen levels and the chemical stimuli. Then this information will be sent to the brain. The brain's main chemoreceptor located in the medulla will then increase the ventilation rate, which is breathing rate, how much we breathe in. These receptors are called the aortic sinus and carotid sinus. Made me sniff then. The sympathetic nervous system works to increase the breathing rate and make the bronchial muscle relax to allow for more oxygen to enter the body, or the lungs, obviously. This system is stimulated by adrenaline, which is released before exercise to help with cardiac output. So adrenaline helps with the cardiac output. The brain, which is the control center of your body as well, as obviously the heart as well. So the brain's receiving all this information, and it makes the inspiratory center, which is part of the respiratory center, send nerve impulses to the diaphragm. So this is part near your lungs, and it helps the lungs to stay be wet, basically, so it can slide off the ribs. So that's the diaphragm. It makes the chest and lungs fully expand, so like that. And then it sends more nerve impulses, causing relaxation and expiration, so breathing out. So that's when it expands, and then that breathes back out, so it goes back, so it's not expanded anymore. And then the cycle continues with the help of the respiratory center. So the body's demand for oxygen and glucose is met through increased blood flow and ventilation. Obviously the breathing rate works with the heart rate, so the heart will beat faster, making the blood go around the body more. And then the parasympathetic nervous system will return the breathing back to normal once the exercise is terminated or finished. So that's just an example of one mechanism that we have. So I'll give you a general know-how of what the homeostatic mechanism includes. So it will start off as normal, so let's say temperature, breathing rate, heart rate, and then an increase or decrease. So if we take up exercising, our heart will beat faster, breathing rate will go quicker, and then a receptor is triggered, and then autonomic center in the brain responds to the changes, say in we're running or it's hot out, and then an effector, which essentially is what helps our body to go back to normal, will be triggered, and then it's returned to normal, and then the cycle can continue. Because obviously homeostasis is working all the time. So I think I've covered quite a lot. I hope that helps anyone who watches this video. My resources used are the BTEC Health and Social Care book, Level 3 National, which is published by Pearson Education, and it's by B. Stretch and M. Whitehouse, so Beryl Stretch and M. Whitehouse, and it's published in England and Wales. So those are my resources used, and then I used in-class notes with my tutor at the City of Bristol College, in Bristol obviously. So thank you for watching and good luck.